Today we will be simplifying expressions with rational exponents. So if you look at the top box, we have if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then a to the 1 over n equals the nth root of a, and a to the m over n power is the nth root of a to the m power, which is the nth root of a to the m power. If m is negative, a is not equal to 0. So we have some numeric examples. Remember back in the day, if we had the square root of x, to solve for x, you would square it, right? If you wanted to get the square root sign to go away. Or notice we can take x to the 1/2 and raise it to the second power. Well, 1/2 times 2, because it's a power to a power, is x to the first, or just x. So I can write the square root of 36 as 36 to the 1/2. I can write it, the cube root of 64 as 64 to the 1 over 3. And I can write the fourth root of 16 as 16 to the 1 over 4 power. In our first example, we are going to simplify. So I would probably start off by saying the fourth root of 625. And we're going to do a factor tree. I know it ends in 25. How many quarters are in $6.25? Well, that would be 25. And the 25 was break into fives. So our answer is 5. Notice for this one, we have the same base of 12 for both numbers, and they're raised to the same power. 1/2 plus 1/2 is just 12 to the first. For the third example, note that we can say the cube root of 12 times the cube root of 18. And now we're going to write it as one giant cube root. Do a factor tree. And notice because we have cube root, we want to have 3 of the same number. So we'll have 3 times 2, which is 6. Take a minute and try the next two problems. These are the answers to A, B, and C. In our next type of problem, we're going to rewrite each expression in radical form. So note to self, in this next example, do you see how the only thing being raised to the 4/5 power is the y? So when we go to write, -2 is not under the 5th root symbol. And I know it's 5th root because remember it's in the denominator. If I look at b, I have a negative power, so I flip it over 1. And then we simplify it further. Because we have the square root d on the bottom, because of 2 in the denominator. And there it is. Let's try going the other way. Let's rewrite each expression in exponential form. So note this time both a and b are under the radicals, so I need parentheses. Now square root is 1/2 power. Now on the formative, if you still have parentheses in your answer, you need to keep going. So in this case, a to the 1/2, b to the 3/2. If we look at b, note that the 5 is not underneath the radical, so it is not raised to the 2/3 power. Okay, so remember, in our thinking bubble, if there are parentheses in our answer, we are not finished. Take a second and try the example you try. Here are the answers to the first A and B example you try, rewriting each expression in radical form. Now try the you try where you rewrite each expression in exponential form. Here are the answers to the second example you try. Let's recall some properties of exponents we've talked about before in the past. So notice, remember, if I have the same base and I'm multiplying, you're going to add those exponents. So over here, we have 6 times to the 1/2 times 6 to the 2/3. I have to get a common denominator. Okay, so it looks like we'll have 6 to the 3/6 times 6 to the 4/6, which would give me 6 to the 7/6. Remember, if you have a power to a power, you're going to multiply those powers. So for the next one, you'll have 3 squared, which is 9. And remember, if you have two numbers multiplied together and it's raised to a power, you have to do the power to both numbers. So 2 to the 1/4, x to the 1/4. If we have a negative exponent, you have to flip it over the 1 and then simplify. So it looks like, well, 1 over the square root of 16, which is 1/4. Remember, if you are dividing and they have the same base, you're going to subtract those exponents. So let's see, 3/4 and 1/2, common denominator is 8. 5 to the 6/8 divided by 5 to the 4/8. That's going to give me 5 to the 2/8, which is 5 to the 1/4. And then the last one, again, it's that power to the power piece. I have to do the cube root of the numerator and the denominator. We get 3 over 4. So if we look at our next example, we want to find the simplest form. So we're going to change the 6th root of 10 to 10 to the 1/6. And the cube root of 10 to 10 to the 1/3. Okay, and we're going to add 1/6 and 1/3 together. So the 10 to the 1/6 will stay 10 to the 1/6. 10 to the 1/3 will turn to 10 to the 2/3, or 2/6, which becomes 10 to the 3/6, or 10 to the 1/2 power. And if you want to turn it back into radical form, you can. Okay, I'm going to do something very similar to b. So I know the numerator is x to the 3/2 power in exponential form. Why is it doing that? And that's divided by x to the 2/3 power. And because we're dividing, we're going to subtract the exponents. So x to the 9/6 divided by x to the 4/6 gives us x to the 5/6, or the 6th root of x to the 5th. Try the next two examples. And here are our answers for this example you try. So again, we're going to figure out what the simplest form is. So if I'm doing the negative 64 to the 5/3 power, first thing I'm going to do is write it in radical form. So 3 is in the denominator, so that means we have the cube root of negative 64 to the 5th. And the cube root of negative 64 is negative 4. Negative 4 to the 5th power is negative 1024. For letter B, I'm going to change the negative 1.2 into a fraction. That does become 32 to the negative 6/5, 1 2/10, which is 1 1/5. I think I said the wrong thing. Okay, so now we're going to do 1 over the 5th root of 32 all to the 6, which is 1 over 2 to the 6, which is 1 over 64. Take a minute or two and try the U-tray. Notice the letter A is a difficult problem because you cannot, square root of 32 is not perfect, it is 4 square root of 3. When you cube it, you have to cube the 4 and the square root of 2. You do get 64 times 2 square root of 2, or 128 square root of 2. Multiply top and bottom by square root of 2 and you get square root of 2 over 256. For letter B, it's just 1/8. Let's do some more simplest form. So again, we're going to draw a giant square root, 9y, and square root of x is x to the 1/2, all cubed. Okay. Actually, I'm going to change it up. Whoop. Let's say we're going to do 9 to the 3/2, y to the 3/2, x to the 1/2 times 3/2. Okay, so 9 to the 3/2 is the square root of 9 cubed, y to the 3/2, x squared. No, x 3/4. Let's see, 3 cubed is 27. And then I'm going to change it back to radical form, so it'll be square root of y cubed, 4th root of x cubed. And I can simplify the cube root of y, or square root of y cubed. So our final answer, 27y square root of y, 4th root of x to the 3rd. If we look at letter B, very similar. I'm going to start off with 27 to the negative 1/3, x to the negative 2, y to the negative 3, and we're going to flip everything down. So 1 over the cube root of 27, x squared, y cubed, or 1 over 3x squared, y cubed. Take a few minutes to try the U-tray. And here are 2 answers for the U-tray. In our last example, we have for a 1/4 inch thick cookie, the diameter d of the cookie is related to the diameter of the ball of dough by d equals 1.6 c to the 3/2 power. What is the diameter to the nearest 1/10 of an inch of a cookie made from a 2-inch ball of dough? So if I have a 2-inch ball of dough, that is going to be RC, right? And our approximation using a calculator is about 4.5 inches. We're done. Practice time.